At PRFI, we design microwave and millimetre wave ICs for our clients. In most cases, these ICs are assembled into packages to provide protection and ease of handling and assembly. This is an evaluation PCB of one of our packaged ICs. It's a 28 GHz Doherty GaN PA. The package is a 4mm by 4mm QFN, which is a commonly used style of package for microwave ICs. Many of the ICs we design are assembled straight into packages, and all of the testing is done on the packaged parts. There are, however, occasions when it's very useful to have the ability to test unpackaged bird eye ICs by direct probing. Our test facilities include a clean room with an RF on wafer or RFOW probe station and test kit to allow bird eye testing to 50 GHz. Suitable miniature probes are required to allow the application of RF and DC signals to the die. The RF interface normally makes use of a ground signal ground contact, or GSG. This provides a high quality transition from the coaxial measurement cables to a coplanar input to the die. For differential signals, a ground signal ground signal ground contact is often used. And DC and bias control can be applied by single needle DC probes if only one or two contacts are needed. In the case when multiple bias or control contacts are required, a custom DC probe card can be manufactured. There are a number of occasions where the direct probing of bird eye ICs can offer significant benefit. It can provide RF performance results for a newly designed IC more quickly than waiting for the packaged parts. Lead times at high volume assembly facilities can be many weeks, and then the packaged parts need to be assembled onto evaluation PCBs. It's possible to perform RF and wafer testing in parallel with the packaging activity, so you achieve results much earlier. If multiple die are to be assembled into a single multi-chip module, it's important to use known good die. If we consider an individual die with say 90% yield, then assembling just 3 of these into a multi-chip module will reduce the maximum yield to 73%. The availability of known good die selected by RF and wafer test will ensure that every module is assembled with fully functional die. Another useful benefit of RF and wafer test is to allow individual parts of a complex multifunction IC to be realized as test structures. These can be then tested individually up to millimetre wave frequencies, and this allows a better understanding of the IC performance and facilitates rapid diagnostics in the event of any issues. So, whilst it's not essential to have the ability to RF and wafer test unpackaged ICs, it can be very useful.